what we need to remember is we will have a main wire between, and then within the main wire, there are a couple of computers are connected, right? Okay. So the next thing is star topology. That is which is very common. And usually you will see this kind of, you know, connectivity within within home. For example, when we connect our computers at home, it'll create a star topology. So the සාමාන්‍ය අපි ගෙදරකදී connect වෙනකොට අපේ hub එකට එහෙම නැත්නම් router එකට connect වෙනවා කියන්නේම it'll generate a star topology. Right. So today we are going to look at the next is the ring topology, or we will also say it's loop topology. So let's start with that. So the next one we call ring topology or loop topology, right? Ring, or we call loop topology. Ring topology. Right. Now, in ring topology, what we have is we are going to have, a couple of computers. Now they are connected as a ring in each other, right? So it will form what we call a ring here. So we will have a ring topology. It will connected to each other, right? Computers are connected to each other. So as a ring. You might not see as a ring, but it's connecting each other. So this is called ring topology. This is called ring topology. Right. So let's write down the advantages of ring topology. Several advantages. We can say when messages interact in between in one direction. So that's why I put some arrows. And therefore, collisions are minimal, right? So the collisions are minimal. And the second one is there will be a high data transfer rate, high data transfer it. Third point, the length of wire smaller compared to star topology. So the wire length is smaller, right? So these are the few things that you need to remember about ring topology. Right. There are some disadvantages as well. So if you write down the problems or disadvantages, the first one is when there's a one computer fail, the whole network fail. When a computer in the network fails, the whole network fails. එක කම්පියුටරයක් හරි මේකෙදි ඩැමේජ් වුණොත් මොකද එකම ඩිරෙක්ෂන් එකට මේක යන්නේ හින්දා so it will fail. Right. Next, we have mesh topology. Right. In mesh topology, computers connected to each other, right? Now, let's say we have computers like this, and computers are connected to each other, right? Every possible way. We can say every possible way computers are connected to each other, right? So let's say I have 4 computers, right? And then computers are connected every possible way. So that means no single direction. So these computers can talk to each other, right? So simply in any direction, they can talk to each other, right? So, and this is called mesh. It doesn't have to be like connect like this. Sometimes some connections might not work. Then we call fully mesh. So mesh topology. Right. One thing I actually forgot about the ring topology. I couldn't write it down about the ring topology. Maybe if you can find some space, let's write down what ring topology is. Right. So I missed it last time. So maybe we can write down here. So what you need to write down about the ring topology is all the computers in a network are connected to one another. in the form of a ring or a loop. So this I actually missed to take down. Messages are passed through all the devices clockwise or counterclockwise. Just to say that it's a one direction. So this happens in a one direction. So that's what we want to emphasize here. So which is called ring topology. So let's move on mesh topology. In mesh topology also, we can write down a little bit on mesh topology. So mesh topology, I told you like computers are connected each other in every possible way. So we can say a mesh topology is a network which each computer is interconnected with one another, right? So that's the point we want to make it here. So we call it a mesh. So that is what we call mesh topology. So let's take down the advantages. When one computer fails, what will happen? Nothing will happen because there will be other connection. When one computer fails in the network, other system will not be affected, right? So it won't affect, isn't it? Second point, recommended the high speed data transmission. So those are the advantages of the system. Then next we have disadvantages. If you look at the number of cables that you need, it's very high. So we can say high cost due to the large number of cables to set up the network. Then the network is time consuming due to complex nature, right? It's complex, simply. You can see because every possible combination you can find out here, which is complex. So now with that one, we finish topologies. To conclude this session, we are going to write down one small subsection on switches and hubs. So let's write down switches and hubs. Right. Now, switches and hubs are usually network devices which use to, create these topologies. Now, when we talk about the topologies, right, these network switches and hubs are quite useful, right? So we are using switches and hubs to communicate each other. They will be looks the same, right? Let me show you a couple of images. So hubs usually number of ports or the number of connection may be limited, but they are look the same, right? Hub, it looks the same in a network if you have a hub. So this picture, I'm going to show you a hub, and then let me show switch as well. It looks the same, right? But then you can have, usually you can have large number of, you know, connections are possible, right? So here you can see a switch again looks very similar, but then you will also see that the number of connections are different, right? So, but how they work is something that we need to discuss. Now, in a network, when you want to send a message, right? And usually hubs transmit to everyone, right? So when we have, um, you know, when we look at, for example, some of the images, right? You will see the computers when they are sending information. So it sends to everyone, right? Now let me show you how it might happen, right? Let's say in a hub, I'm going to use, you know, right? So let's say we have 4 computers, and let's say I want to send information from one computer to another computer, right? Yes. Let's say we will have like this. Let's say we have a situation like this. And let's say we have a hub, right, in between. So in the middle, let's say I have a hub. So this indicates a hub. So now what happens? Let's say I want to send some message. Let's say from here to here. So let's, yeah. So let's say I want to send a message to this computer, right? So this is what I want to send from here to here. But actually what will happen, it will not only send this information to this computer, it will actually send to everyone. That is what hub does. Hub, once it gets, it sends to everyone, right? It sends to everyone. So which is, these ones are not needed. We want to send it from here. So this is hub. This is what will happen with the hub. Hub will send it to everyone, right? Then if you take switch, switch is actually smart compared to this one, right? So yeah, let me use the same figure, right? So let's say I'm going to use the same set, right? We'll copy it. Let's say I'm going to do with a switch. Switch is actually smart. Switch will be smart. It doesn't send this to others, right? So if you take, let's say, like this, it won't send it here. And let me remove this symbol. So usually symbols are slightly different. So I will replace it with the, different symbol. Right. Now, as you can see, what will happen, right? It won't send it here, right? So it could be a network, right? But it will send it only to this computer. So that's the interesting point, right? It won't send to everyone in a network. So that's what hub and switches the difference, main difference. Okay. So let's write down. We can say that, okay. We will say that, okay. Hubs and switches are common devices that could be found on networks. That's the first point. So usually, commonly, you will see this in a network. The second point, a hub forwards incoming data to all outgoing connections. So you see what has happened here, right? If you go back, hub, any incoming, send it to all the other, right? That's what it means. Next, a switch receive data in one connection and forwarded into destination. Therefore, we can say the switch is more intelligent than. Okay. So interestingly, now we know the difference between the hubs and switches. They are network devices. So once you have network devices, uh, what hub does, whatever incoming will send it to all the other computers in the network, whereas switch is intelligent, it sends it to whoever is expecting to receive it. Right. So let's move on to the next section. It is 6.6 Media Access Control or MAC protocol. So MAC is a unique address which you can use to identify devices in a network, right? So each computer uniquely identify using this address. So we are going to look at what is the role of this MAC protocol, and we discuss the unique names given for each of these devices, and so that we can identify who's the sender, who's the receiver in a network, right? Okay, so let's start. So under this one, first of all, we need to understand the local area network, what it is, what is it, what are the advantages of using a local area network, and then how do you identify devices. We know two things, IP addresses earlier, that in any computer in the internet or a network, we can uniquely identify. Similarly, we can identify devices as well. And that is exactly what we need to discuss in this part. Now, after finishing that one, we are going to also going to look at to understand, right, how the transmission happens, how data is transmitted between devices, the techniques, right? So that is the main. So let's look at what local area network is. So let's write down local area network, or in short, we say LAN, right? When we say LAN. Now that is the smallest type of network that we can see. Right? So we have already discussed earlier that you can have LAN, MAN, and WAN. So let's start with the local area network. So the computer network we will create within a building. Within the building, we can call it as local area network. So if you want me to give you some examples, so the examples are like, if you take the network within a school or a university, we can say this is comes under local area network. And you are getting a lot of advantages of creating network. We already discussed this, but let's summarize. You can share resources, which means both the hardware and software. For example, you can have a printer in a network, and all the computers in the network can send print to this computer. And then when you want to purchase software, you can purchase software for one machine and then you can use it, or the other computers in the network can access that. Very secure environment you will get. Usually security we are not going to see, right? Security aspect we are not going to focus a lot in without a network. But if it is a network computer, usually you have logical security, which means username and password, the firewalls we will use. Simply here, what we can say, only authorized users are allowed, right? Whereas the personal computers, you don't sometimes have any username, password, anybody can log in. Then ease of communication. So the meaning of this is users can communicate by email or especially instant messenger. You can have chats within the local area network. Right. Devices. Right. The next point we are going to discuss, identifying the devices. Right. When you say identifying the devices, which means how do you identify, for example, computers in a network, right? So there are two ways we can use. Two ways used to identify devices in a network. Right. So that's the point that I want to make. Yeah. First technique is we can use IP address, or we call logical address. We already have discussed this idea earlier as well. Right? It's called logical address. Right. Now, for example, if you take a command line interface, right? And if you type, there are some commands. If you type it, ipconfig, for example, this will give you an address when you're in a network, right? So for example, this is the IP address of my computer. So that is 192.168.1.4, which we call IP address. So in IP addresses, usually each number can go from 0 to 255. That is the maximum value, should be within 0 to 255. So you need 8 bits for that. 2 to the power 8 is 256, right? And 8 into 4, you need 32 bits to represent, IP address, right? So these numbers are assigning by usually the internet service provider, such as Dialog or Mobitel or Telecom, right? Okay. So let's write down IP address or the logical address. We can say this is what we call, right, a temporary address given to the devices in a network, right? So this is a temporary address given in network. IP address is a 32-bit number which uses computers to communicate each other in a network environment. There are 4 8-bit numbers in the IP address. So you have already seen which are separated by dots. So example, one possibility is 108.177.97.105. You see, there are 4 numbers separated by dots, and each number goes from 0 to 255. Right? These numbers are given by an internet service provider, or in short, we say ISP. And the valid range of numbers are 0 to 255. Right, make a note of this. Right, the next one is we need to discuss MAC address. This is also known as physical address. Right? The point that I want to make it here, it's a unique address. Right? MAC address is a unique address. And it's unique for the computer. So we can say MAC address is unique and permanent. So this is given by manufacturer, right? And the size of the address is 48 bits. So when I say 48 bits, there are 6 into 8 bits blocks. And the first 3 blocks are used to identify manufacturer, and the last 3 blocks are used to identify the device. Right? Example, we can say 0C, 7, 0C, 7A, 15, 6D, F6, and then 10. So this is one example for MAC address. So the next topic we are going to discuss is called frames. Right? This is again a subtopic. Now, frames are quite useful. Now, when we want to send the data from one computer to the other computer, we will use different techniques, right? And data will be sent and received in different levels, which we are going to discuss later on. But for the time being, in one of the layers, which we call data link layer, the data we put into frames. Now, frame means something that, we have some data to send, and the data we will put in the beginning and end of the data, we put some information, right? Which creates a frame. And in here, in the header section, right, you have the MAC address. So that's what we want to discuss under this one, right? When you want to send it. So the frames we are going to discuss under, network layers. We will discuss, there are different representations are there. So that part I will discuss later on. Right. Now, to talk about this, what this is, so I will discuss three different types of the layers. Let me take some chips, right? Say we have some layers, right? Here is one layer. Let's say the third one, it's called network layer, right? And then let me take a copy of this, right? And then the second one, we have what we call data link layer, right? We have data link layer. Now, within the data link layer, right, the data will send as frames, right? That's I told you, like we are going to discuss in detail later on. But for the time being, yes. So the lower layer is called physical layer, right? Ones and zeros, we are saying, sending data as ones and zeros, which we call physical layer, right? Here are the three layers. That's the first thing that we need to understand. Likewise, there are many others which we will discuss later on, right? For the time being, we are not going to discuss in detail, right? So we have these layers. Now, when you look at data link layer, within this one, data has three parts, right? So I will draw separately. So data link layer, so data has three parts. First one, you have some header information. So it's called header, right? And then you have actual data. Let me copy paste, right? So the second part is called the packet or the data. We say packet. That is actually data. Right? And then like header, we have a trail part as well, right? So at the end also, to mark this is the end, we have like header, we have some bits added in the end, right? So this is called a frame. So this is called a frame, and frame is what we use to transmit the data. Now within the header part of this, right, we have MAC address. That's what we want to say, right? Maybe you can draw these three just to say that, okay, we'll draw in different color this layer. So we'll use this color, and we have three parts, right? Okay, so same thing, and this is called frame, right? So let's write down this in words. At the data link layer, data are encapsulated into the frame. Okay? So data like frames, we call it frames. Okay. And it consists header, data, and trailer. The header consists of MAC address of sending and receiving devices. Okay, so we have a sending and receiving devices of this. Okay, frames we will discuss again later on. We have a separate section on discussing these different types of layers. Right now, what I want to discuss is at the second layer, which we call data link layer. The data are sent as frames, and the data actually from beginning and end, we have a header and trailer. But the header, we have information about the sending and receiving, MAC address of sending and receiving devices. Right. As the next one, we are going to look at what protocol is. Right. So when you talk about the protocol, it's an interesting point we need to discuss. Whenever we want to send data between two network devices, we have to define what the OD is, what the format of the data is, right? And for that, there are many protocols, and then we are now going to talk about the MAC protocol. MAC protocol, and we normally use this for common shared medium communication, and then we can guarantee that it won't, minimize the collision, right? So let's write down under this one, the protocol. A protocol is a set of rules used to communicate devices in the network without any collision. Without any collision. Right. Now, and then what you want to say, so there are many things that we can discuss this, but let's talk about bus topology. In a bus topology, you remember the bus topology? We have a main wire and then we have computers. If two devices transmit data in opposite direction, now what happens? The data gets destroyed due to collision. So therefore, to avoid this situation, a protocol needed. Right. So we need to avoid this. For that, we need protocol. Now, when you talk about the protocols, we have to discuss two implementation, Aloha and slotted Aloha and Ethernet, right? So let's see what those are. Okay, so in this part, we are going to talk about what Aloha protocol, pure Aloha protocol is. Now, in this one, what happens? The first computer will send the frame number one. So that's all it will sending, and then nothing will, collide with the first frame. But then, if you look at the frame number two, it may collide with 357 from other computers. And again, 4 and 8 may collide, but 6 is free from collision, right? So let's write down how the transmission happens. So the transmission happens with a few things. So we can say the transmission. So simply it will start checking whether the frames are free, and then it will forward signals to the media, but then it will wait for acknowledgement. When it receives by the receiving end, we normally get acknowledgement. If we didn't get the acknowledgement, then we will if you get the acknowledgement, you will forward the next signal. Otherwise, you will wait. You will send the frame again. Right. Now, in our diagram, we discuss 4 devices in the network, and under the 4 networks, right, we discuss how the transmission happens, right? And then we are using a single transmission media. So if this is the case, then we have sent the first device. When you send the first frame, no collision, but with the second frame, there are several collisions. Okay, let's take down this. අපි කිව්වා protocol කියලා කියන 아무ත් දෙයක් නෙමෙයි, set of rules how the transmission should happen, right? So instead of just sending the frames, now we will have slots. That means some time frames where you can send it, right? So compared to previous one, now here the times are slotted. There are slots of time, and then you can send only one frame to a slot. So which means now you have less collisions. So let me show you a similar figure like in previous case. Right now in this one, what you see is This is called slotted aloha, which means now we have 6 slots are there. And you are sending the same way. For example, station 1, there's no collision. Station 2, sending the third frame, but there's a collision with station 3. The station 1, 2 collide with 7. But 4, there's no collision. 8, there's no collision. 6, there's no collision. So compared to the previous protocol, now we see there's an improvement, right? The reduced collisions are there. So let's draw this and then I will give you the